Thank you very much. Despite the best efforts of the commentators on Fox, there is only one species of modern humans, and so I'm just going to assume that you're happy with that. There is another anniversary this year, and this concerns this man, and it's 200 years since the year of his death. And that has meant that those of you who had the opportunity will have had at least one opportunity to hear this magnificent oratorio that Joseph Haydn wrote. And in one of the arias, Raphael says, "Now the heavens shine in all their glory. Now the earth is splendidly adorned. The air is filled with fluttering plumage, and the seas are swollen by the fishy host. The earth is pressed down by the weight of beasts, but all was not accomplished yet. That being was still lacking from the whole, who could look down upon God's work with gratitude and to praise the goodness of the Lord." Now, as I was coming from the nation's capital, where learning and culture are in very short supply, and coming to a place where they're not in short supply, I thought I should at least start with something to do with culture. So there are three possible originations that I want to address. The first is the origin of the modern human, and this is with apologies to Simon, the modern human little twig of the tree of life. The origin of the genus Homo, however you want to define that, and the origin of Homo sapiens. So there are at least three ways that you could discuss the origin of modern humans. So here is the tree outside of my office, and you can see I put modern humans here. In the last regime in this country, I had them down here somewhere, but we're now sort of creeping back up the tree. So the first of the things that one wants to address is where do modern humans fit on the tree, and who are our close living relatives? Now, here are modern humans, here are bonobos, here are common chimpanzees, here are gorillas, and here are orangs. Here is the surface of the tree, and the surface of the tree, as Simon says, is where all the living creatures are. And everything that's ever been alive in the past is in the tree. So here's the surface of the tree, and down here is the inside of the tree. Now, these dates are approximate, but nonetheless, I think they are reasonable approximations. And the hypothesis is that modern humans and bonobos and chimps shared a hypothetical common ancestor 6 million years ago, and they shared a hypothetical common ancestor with the gorillas and so on and so forth. So this is in a sense the answer to the first question: where do modern humans fit onto the tree of life? And what I do when I go to work every day is to try and work out what's going on in this deceptively simple red line here. And is it just a succession of anagenetic changes from a more ape-like creature down here to modern humans up here? But we'll return to that later on. So the first thing, so if one's trying to reconstruct this, there are two ways that you can reconstruct it. One is that you can try and look for the subunits in the tree of life, which are the lines. They are the branches and the twigs. And if you can find the structure of its component clades, then you can reconstruct whatever part of the tree of life you're interested in. So what is a clade? Well, the definition of a clade is all of the taxa, no more and no less, that are descended from the most recent common ancestor. So here's an example of a clade. These cars are all descended from a common ancestor. A make of car like that is a reasonable approximation to what we mean by a clade. The other thing that you can look for when you're investigating the tree of life is that these four cars all share a recent common ancestor, which is not shared with any other makes of car. The other thing that you can look for is a grade, and a grade is a group of taxa that shares a suite of similar adaptive things. In other words, to be in the same grade, you should be eating much the same as the other members of the same grade. To be in the same grade, you should move around in much the same way as the other members of the same grade. So here's an example of a grade. Here is a Toyota clade, and there is a Land Rover clade, and there is at least one member of the Toyota clade, which is an SUV, and there are at least a couple of members of the Land Rover clade, which are also SUVs. So the three SUVs are functionally similar, and they share a common ancestor, but it is not their most recent common ancestor. You know, maybe it's a Daimler-Benz, but it's not a relatively recent common ancestor. So in theory, reconstructing clades ought to be simple. The more morphology you share, the more evolutionary history you share, and that should be the end of it. However, that would be the end of it if it wasn't for something called homoplasy. And the definition of homoplasy is shared morphology which is not inherited from the most recent common ancestor. And there are various ways that you can estimate this, but certainly in the great ape clade of the tree of life, it looks as if just about 1/3 of the morphological features that you might use, because they're well represented in the fossil record, just about 1/3 of those morphological features are telling you wopses about phylogeny. So in other words, it's a bit like advertising. Everybody that knows that about half of advertising is wasted. The question is which half? And we would like to know whether you can predict which morphology is more likely to be prone to homoplasy, and I will return to that later in the talk. So here is the tree outside my office window last week, and here is the tree outside my office window in the middle of the summer. It's not quite as bad as this, but the leaves obscure the branching pattern much in the way that homoplasy helps to obscure the branching pattern of the tree of life. So this is what the hominin fossil record looks like to somebody who's a pretty rabid splitter, which is what I am. But at least the advantage of being a splitter is that you can relatively easily recombine things. It's extremely difficult to take things apart. It's amazing how difficult it is. So here are modern humans. Here is millions of years down here. And this is a diagram which is it's not about clades, it's about grades. And the grades are extremely complicated and sophisticated. They are light green, yellow, purple, and this light blue and the dark blue and red. So as long as you're not colorblind, you can just see what I mean. So here are modern humans. And then there is this grade here, which I've called pre-modern Homo. And these are creatures that have a postcranial skeleton much like us. They have limb proportions much like us. But they do not have, in general, some of them have large brains, but some of them have relatively small brains. Some of them have brains that are only 600 or 700 cc's. So in terms of a grade, they share the same sort of locomotion. Most of them seem to be, you could probably assume that they have an archaeological record. In other words, they're capable of making things. But as we will see later, that's not saying a great deal. Then these sort of light blue, the turquoise ones, these are in between. And they're in between these yellow ones and the blue ones. The yellow ones I called archaic hominins. And they are creatures that if you met them out in the street, they will be capable of walking upright, but that's not maybe what they did all the time. Their limb proportions would be more ape-like than modern human-like. And their brains would all be, there is not one of these which has a brain much larger than about 500 cc's. Some of them have conspicuously large molar and premolar teeth, so we call those megadont, which just means having large teeth. The green ones down here, I've left this on here because a couple of weeks ago I would have said that these are possible and probable early hominins. And the reason I put the probable in there was because what evidence there was of Ardipithecus ramidus before a couple of weeks ago would suggest to me that it might have been an early hominin. Now I've looked at the evidence that has been published, and I would relegate that to being a possible and probably not very likely hominin. So despite the conclusions in the papers in Science, I think the evidence would suggest that it's less likely to be a hominin, not more likely to be a hominin. Now there are no lines on the diagram because there are very few places in the diagram where I think you can sustain a hypothesis of ancestor and descendant. One of them, and I think it's not, one of them might be that Ardipithecus cadaver is ancestral to Ramidus. One of them might be that Australopithecus anamensis is ancestral to Australopithecus afarensis. These two might be this might be an ancestral descendant relationship, and maybe the early African form of Homo erectus is the ancestor of the more classical sort of Homo erectus. But other than that, it's very difficult to draw any lines on that diagram, or at least any lines that I think, lines it would be responsible of me to draw on the diagram for you. So what about the origins, the other sort of origins? We've already talked about where modern humans fit into the tree of life. What about the origins of the genus Homo? Well, these sort of, the turquoise forms, the reason why I haven't put them in blue is because they're a sort of a transitional, they're a sort of transitional form. The postcranial skeleton is more like the yellow ones, yet in terms of brain size, the brains of these are a little larger than the yellow ones, and the brains are on the way to becoming the size of the blue ones. So if you suggest that actually the turquoise ones really belong to the genus Homo, which I have my doubts, then the origin of modern humans, as in the origin of Homo, would be something like 2.3 million years ago, but that's almost certainly before that, because these creatures were likely to have been around sometime before we happened to find the fossil evidence for them. Now, if you don't like the turquoise ones, then the origin of the genus Homo would be around a couple of million years ago. Then if you want to think of the origin of modern humans as in modern humans, in other words, people that look like us, I'm not going to say behave like us because that's an even more complicated story, but look like us, then you have to wait until a couple of 100,000 years ago. That's where you see the oldest evidence of modern humans. And you see that in the form of the cranial remains from one site in Ethiopia, and, well, actually a couple of sites in Ethiopia. Now, there's another way of looking at this fossil record, which is a much less speciose interpretation, and that means that you have to do some lumping. And there are people who say that Homo sapiens ought to include everything after the last likely speciation event in the hominin clade, in which case you would have to include Homo erectus into Homo sapiens. They would allow probably you to have habilis. They would lump all the megadonts into the species that has priority, which is Paranthropus robustus. They would allow maybe the distinction between Australopithecus africanus, which is the Australopithecus species that has priority, and maybe afarensis. And they would lump all the the light green ones into a single species. Now, of course, if you do that, you can also do this, which means that human evolution is a pretty simple thing, apart from a sort of, mistake on a Friday night back in the Pliocene. It's a straight shot from things that are more ape-like to things that are less ape-like, and in that case, the origin of modern humans would be just less than a couple of million years ago. I don't happen to think that this is a sensible way of looking at human evolution, but nonetheless, it is a way of looking at it, and it certainly gets you away from all the problems of relationships, because essentially either you're an ancestor or a descendant, or you're both. So it really gets rid of all those research problems, and that would be a shame because it will put me out of a job. So the only places where you would think of origins would be either here or here, and this is the 2.3 and the just less than 2 million years ago time. So to go back to the bigger question, one sort of null hypothesis is that the only thing that we know is that we have an ancestor. And therefore, the null hypothesis is that if we find any fossils, they belong to our ancestors until you prove otherwise. So that's one way of looking at the fossil record. So that way of looking at the fossil record would assume that every bit of the fossil evidence that you find is going to be on this red line somewhere. And the fossil evidence that you reckon is more closely related to modern humans than it is to any other living taxon is going to be somewhere on this red line here. Now that's okay, but I'm sorry I couldn't find a Roman Catholic to talk about, but you have to do with the Reverend Thomas Bayes. He said that you should use experience if you're framing hypotheses. You shouldn't just assume that you've walked into a room where there is nothing known. And if you use experience when you are framing hypotheses about what sort of creatures you're finding in the fossil record, and then if you look at the other parts of the tree of life, you find that if you go to the other parts of the tree of life, there are lots of twigs on the tree of life, lots of branches that don't reach the surface. In other words, they are extinct clades. So if you say, well, okay, well, let's just entertain the possibility that some of the fossils that we're finding might belong to extinct clades. So instead of assuming that everything is on the red line here, life might be like this, okay? There might be some extinct clades in the hominin part of the tree of life that have no living representatives. And certainly Paranthropus robustus would be, if you're a lumper, would be one of those. It might also be the case for the chimps. There may be extinct clades which are related to the hypothetical common ancestor of chimps and bonobos and modern humans and so on and so forth. So if you find a creature in Africa at 4.3 or 4.4 million years, instead of only entertaining the possibility that it's here, that creature might be there, it might be there, it might be there, and it might be there. So I think we need to look at some of the early evidence, some of the evidence which has been assumed to be ancestral to modern humans in a slightly more eclectic way, and at least entertain the possibility that what we might be looking at is one of these extinct clades, a member of one of the extinct clades. Now, one of the reasons that people say that this is just imagination is that the things that make us so distinctive, like the fact that we stand upright and walk bipedally, They are such profound evolutionary changes that it is completely inconceivable that they occurred more than once. So they're willing to entertain this, elsewhere in the tree of life, but there is a sort of, a NIMBY sort of notion that, not in my backyard. I don't mind conceding this sort of thing going on in the nematodes. I don't mind, conceding this sort of thing going on in the fish, but I certainly don't want to concede that sort of thing going on in the hominin part of the tree of life or in the great ape part of the tree of life. And this diagram I want to thank Lisa Novell for, who's one of the graduate students. This is the underside of a mouse cranium. These aren't to scale, by the way. This is the underside of a mouse cranium, and this is the foramen magnum. Here is the underside of a modern human cranium, and here is the foramen magnum. Here is the underside of a gorilla cranium, but it might as well be a chimp cranium because they're very similar. And here is the foramen magnum. And one of the things that's happened, and people say this can only have happened once, it's such a major change, is that the foramen magnum has migrated forwards, which has meant the integrated migration of all the holes in the base of the cranium for all the nerves and the vessels and what have you. And this is such a big deal that it can only have happened once. And that means that something like bipedalism then becomes a sort of golden character. If you can demonstrate that a creature is bipedal, ergo that creature is a hominin. That's if bipedalism if it only happened once in the hominin clade. Here is these are newborn mice, and this is the wild type mouse, and this is a knockout mouse which was being used by a group at the University of San Antonio Medical School to work on striated muscle tumors. These particular knockout mice, they have an extremely high incidence of striated muscle tumors. And this group are interested in striated muscle tumors. These only occur in something like 3,500 newborns in America per year, but it's a very nasty tumor to have, and the group is interested to try and find out whether you can prevent these. So these mice have a lot of striated muscle tumors. They also have a foramen magnum, which is much closer to the middle of the cranium than in the wild-type mice. So this could be a chimpanzee cranium, and that could be a modern human cranium. The differences are as profound. The genetic differences are relatively trivial, and what's interesting is that they overlap with the differences between modern humans and chimps. Now that may just be good luck, but nonetheless, it's an interesting observation. The point I'm trying to make is that these sorts of changes, although they look massive and significant, they are relatively easy to do. And evolution sort of copes, and morphological integration manages to make things work and match with such changes. One of the ways of maybe trying to get at the homoplasy problem, or at least trying to identify where it is to extract more evidence from the existing fossil record. And this is the work of Matt Skinner. And what he's been doing is micro-CTing the teeth of fossil hominins. Now, as somebody who's a dental morphologist, this is a disappointing tooth because it's lost a lot of the enamel morphology on the outer enamel surface. But if you micro-CT it, you can get the computer to work out the differences between where the enamel and the underlying the dentine is. And this is a map. This is a three-dimensional map of the enamel-dentine junction. So here, if you micro-CT these teeth, you can actually get the information which has been lost because the enamel has been worn away. Because with relatively few exceptions, the enamel just gets laid down on the dentine. It's a much more complicated process than that, but nonetheless, the outer enamel surface, with one or two exceptions, matches the shape of the enamel-dentine junction. So you can take something that a cladis will have scored as the same thing, and this is the mid-trigone crest. Here's one in a chimpanzee, and here's one in a Neanderthal. Yet, if you look at the enamel-dentin junction, the morphology of the mid-trigone crest at the EDJ is different. So what looked like a shared character is not actually a shared character if you sort of drill down and you look at the morphology in more detail. So we've done that with the mid-trigone crest. We've also done it with these extra cusps here. And it's really interesting. I don't have time to go into the results, but what we have been scoring as yes, yes, actually turns out to be yes, no. And so although I agree with Simon that there is a lot wrong with cladistics, some of what's wrong with it might have been the way that we were doing it. And maybe if we get more information about morphology, we might get results which are more interesting. The other thing is that if you capture morphology in much more detail, then you may be able to see differences that you were not able to see when you were capturing morphology much more simply. When I was a graduate student and I was interested in the dentition, all I did was measure how long a tooth crown was and how wide it was. Now you can actually capture, using 3D morphometrics, the shape of the ridge which joins the crest on the enamel-dentin junction, and you can capture the shape of the base. So then you would have a family of points, but the colors seem to have been leached out. But there is the average ridge curve. I'm sorry. There is the average ridge curve. Oh, no. Okay. The point is that with this much more detailed way of capturing morphology, we can actually discriminate in multivariate analysis between the first molars of two subspecies of the common chimpanzee. Now, you're not able to do that if you capture morphology much more crudely. So I think there is a possibility of us getting more intelligent, not only about homology, but also about recognizing species. So to summarize, we know where modern humans fit into the tree of life. Now, despite that, there is a director of a science museum in Buffalo who insists that the orangs are the closest relatives of modern humans. That says more about a science museum in Buffalo than it does about the evidence. There isn't the vast majority of evidence, be it molecular, be it evidence from the genome itself, or be it evidence from gross morphology, that suggests that modern humans and chimps are each other's closest relatives. Most of us are convinced that the hominin twig of the tree of life has several extinct branches. More fossil evidence is essential for reconstructing phylogeny, but you can also extract more evidence from the fossils that we already have. So I think, it's very easy to say, we need more fossils, we need more fossils. That doesn't exonerate us from thinking more intelligently about the fossil evidence that we have. And I'm convinced that with more work and with more thinking about things, we can actually make a better job of understanding the evidence we have, and not just wait for the next lot of evidence. Obviously, new fossil evidence is important. I'm the last person to downplay that, but it's not. But unless you know what to do with it, it's not the answer. So I want just to show you this picture of Charles Darwin, and to say that I'm sorry I couldn't find a Roman Catholic oratorio to quote from. I think this is a wonderful portrait of Cardinal Newman, but I looked through the Dream of Gerontius, and there really wasn't an appropriate quote from the Dream of Gerontius. But you guys certainly know how to dress up. It's a wonderful portrait. If you haven't seen it, it's in the National Gallery in London, and it's just a sumptuous portrait. Thank you very much.
Could you, Ken Miller from Brown University, could you be more specific about what the characteristics are of the recently described Ardipithecus fossils that lead you to sort of push it away from the human lineage?
I mean, it's very difficult. You know, this material has come out in this sort of huge bolus of information, and so it's not been possible to look through the information in as much detail as I would like to have done, and indeed I have some of it in my bag to look at on the way back. One would have to say that the evidence for it being a biped, I think, is pretty sparse. Most of the inferences about the bipedality are from a pelvis which is very squashed. It looks as if Rush Limbaugh has mistaken it for a toilet seat, and this pelvis is completely squashed, and they have tried to reconstruct it, and I think they've done a terrific job of trying to reconstruct it. And there are some features of the reconstruction which are consistent with it being a biped. But having said that, if you look at the rest of it, if you look at the foot and the talus, which is rejected out of hand in that paper as being informative about locomotion, it's very difficult to see that the talus can be uninformative about locomotion. It's right in the middle of the foot. And you could lose that talus in a drawer of chimpanzee tail. And so I think the evidence for it being a biped is not that great. The reduction in the canines is interesting, but you see that that has occurred a couple of times independently in the hominin clade, and so I think a reduction of the canines is not something I would choose as a sort of a golden character. If you have reduced canines, this has to be a hominin. I will be comfortable seeing several Miocene apes having reduced canines and sharing that with the hominin clade. So for various reasons, I just think it's one hypothesis that should be entertained is that it is a hominin. But I think if it was me, I would have spent a little time thinking about other hypotheses rather than assuming it's a hominin and then having to sort of rearrange all the chairs on the deck of the Titanic in order to accommodate it in the hominin clade. I think I've already completely blasted what's left of my career. But
general question, Jim Salmon from Loyola in Baltimore. What you talked about morphologies, and I was wondering, how would you classify, what does it mean to be a hominin besides this bipedalism or whatever you want to call the morphology? How would you, what kind of characteristics would hominin have, let's say, would do?
Sorry, what kind of characteristics would it have?
Such
or
as
what would
make fires, that sort of thing.
When I was a lad, there was a book that we read to me, which was called Man the Toolmaker, and man was essentially defined as, if you made tools, you were human, or you were a human ancestor. So if we went back, I'm not sure I have the technology to do this, but if we went back to this sort of diagram here, all you would need to do is to find out when the earliest stone tools were made, and you would need just to hang a little label that said Homo on there. Now we know several things, is that we think that more than one sort of hominid was likely to be capable of making very, very primitive stone tools, and we also know that there are several groups of primates, non-human primates, that modify things. And so I think the notion of using the manufacture or the use of tools as a label for either the genus Homo or the hominin clade is probably not something that we should do. Fire making, it's very difficult to work out whether a fire is controlled or whether it's a wildfire. When a tree catches fire naturally with lightning, and it'll burn down, and there'll be a pile of charcoal at the bottom of the tree, and it'll look very like the pile of charcoal that you would get in a hearth. Now, there is a difference between the temperature in a natural fire and in a controlled fire, and folks have been using those methods to see if they can identify the earliest controlled fires, but the evidence, it's probably not much older than 1 million years. So lots of things like that. We didn't come as a package, our life history evolved at one momentum, our limbs evolved, our brains evolved in a different, so the package only seems to come together about 100 or a couple of 100,000 years ago in a way that we would recognize as doing modern human-like things. And even that, will have people scratching their eyes out over how you define what modern human behavior is.
Bernard, you have, Francisco Ayala, University of California, Irvine. Bernard, you have spoiled my day, because after all the series of papers on Ardipithecus, I was so happy that now there was enough evidence to put them in the hominin tree. And I have so much respect for you that now, whenever I write about this, I will have to say, I don't know. But I hope you plan to publish soon your views of Ardipithecus, and I don't mean waiting for your encyclopedia and your textbook. Every year they are going to come a year later with some article in Science or so. But I have, so that's my hope, and I don't know what your plans are. But why don't you tell us a little bit about your current views of Floresiensis?
Floresiensis, for those people who have been living on Mars for the past 5 years, Floresiensis is also known as the Hobbit. And this is a creature which has been found on the island of Flores in a cave called Liangbua. The oldest remains are probably 70, 80,000 years old. The most recent remains are just less than 20,000 years old, maybe even less than that. And if there's one thing, that you could have said, a group of paleoanthropologists hanging around the bar at the American Museum of at the American Association of Physical Anthropology, we know everything there is to know about human evolution in the last 100,000 years. There's nothing that, that's going to surprise us. And then comes Homo floresiensis, and there are two alternative explanations for this. One is completely crazy, and the other is reasonably logical. The completely crazy one is that there is nothing to explain. These are just modern humans that have one of a number of syndromes that just happen to make their carpal bones look like the carpal bones of archaic hominins, and their skulls to look like the skulls of early African Homo erectus. But these are diseased people, and we should not be wasting our time trying to interpret these within the range of normality. And of course, if you go back and look at the history of paleoanthropology, that's what everybody has said. Every time somebody has found Homo neanderthalensis, Homo erectus, and so on and so forth. So I think they're just an amazingly interesting organism, which I think is consistent with them being a dwarf form of either early Homo erectus or maybe something even more primitive than that.